Hey, I'm Luke with S&S Diesel Motorsport. I wanted to talk a little bit today about high pressure pumps, CP4s specifically, which continue to be a hot topic and a discussed part that's a critical piece to a lot of vehicles. There's lots and lots of vehicles worldwide now, and not just pickups, that use common rail fuel systems, and a lot of them are using CP4 style high pressure fuel pumps. There's some reasons for that, but there's some drawbacks to that. So we'll talk about that a little bit. We did a video previously talking a little bit more detailed about the design and operation of a CP4 versus a CP3. Check that one out if you're interested in how they're different and why we prefer the CP3. The CP4 is a very modular design, which is the beauty of it really from a manufacturing or assembly perspective. Almost all of them are very, very similar overall internal and base design. This is an LML Duramax 2011 to 16. Duramax, for example, has a CP4. It's got a gear pump on the back to supply the high pressure system. A lot of applications just have an electric supply pump and they don't have a gear pump on the back. The 19 to 20 Ram, like this one, has a gear pump on the back, but overall the rest of it is very, very similar to any of the other designs. This is a 2020 Ford base CP4 here. You can see there is no gear pump here because they rely on electric pump, just like all the 6.7 Ford platform is. There's many of them, BMW applications, Volkswagens, eco-diesels, lots and lots of them use a CP4 of some variety. They're almost all very, very similar as far as the pumping elements and the main base design. They just have potentially high pressure outlet heads oriented in different ways for fuel lines or plumbing in the vehicle, or with or without a gear pump are the main differences. Overall, they're very similar though. The base function includes a two-lobe cam like this. It's a very aggressive two-lobe cam, you can see, and there's two pumping heads. So cam is in the body. There's a roller and a spring and a plunger. So this is the head, as you can see here, that sits on the pump body. This is the outlet valve, goes to the high pressure system. There are no seals in this. These pumps and these systems work at such high pressures that a traditional seal or piston ring type seal or something like that really just wouldn't even live. So the sealing mechanism is literally just really, really tight tolerances and clearances between the bore and this precision ground DLC coated plunger. So this plunger, basically the whole mechanism is just this plunger pumping. There's an inlet valve that allows fuel in, and when it pumps, when the cam rotates and pushes this assembly up, then the plunger is moving up and down. So as that's moving, this mechanism is going up and down. The problem, and how a lot of these fail, I just grabbed 2 to 3 CP4s out of a core pile here a couple days ago just to check to see failure modes, to kind of gather more info. If you have a CP4 and you suspect a failure, the way to check, the telltale sign, is take the 2 bolts off the metering unit, pull the metering unit out. If you're a lucky winner, it's going to have a bunch of metal shavings and debris on the metering unit. Unfortunately, that also means that the rest of your high pressure system is compromised, because from there it goes to your rails, injectors, and everything, and it's a very, very expensive and painful repair. The pumps, 2 of the pumps that I just pulled out failed in a way that is fairly common, and unfortunately there's really no fixing it with anything that you can do other than trying to maintain the cleanest fuel possible. But as this is rolling, there's a roller here. As that's rolling, what can happen, and what happened in a couple of these examples that I just grabbed, was this rotates. There's nothing that keeps this from rotating. So it normally rolls like this. If this rotates, it stays, and there's no saving that. You could have engine oil in this thing and it's not going to last forever. And with fuel, it doesn't matter what you've got going on, when this is turned 90, it's going to start digging. And it'll end up, here's one that is example just from a couple days ago. Bucket rotates, roller no longer rotates, and then you just dig a groove. And then that sends shrapnel through everywhere. The problem with that, so that's one design flaw of the CP4. The problem with that is the flow path through the CP4 feeds the metering unit and then your injectors straight from the cam box of the pump. So there's some question and confusion in some of the market on how that works through here, and why we designed the CP4 bypass kit, aka disaster prevention kit, to remedy that. In a normal application, this is a power stroke pump, and a little hillbilly cutaway I just did yesterday to show how this works. Fuel comes in through the blue. Basically, blue color is supply side, yellow color is return side. Fuel comes in from your tank to your electric supply pump, through your filter, and then to the pump inlet here. It goes through a screen and then into a drilling, which feeds into the pump case body. And it immediately goes straight back out into this port here. So through the inlet, through the screen, into that hole, turns right back around and comes into this hole. Then this drilling here goes up to the metering unit and then supplies the high pressure pumping heads, which would go up here, and then your injectors. That's the normal flow path. The whole time that's happening, this is a regulating valve here. Fuel, there's a screen on the end of it, but the same fuel that goes into the case and feeds the metering unit right here at this junction also flows through this valve, and it regulates the pressure in the system, and then out through the return back to your tank. So the yellow being the return side. There's some pretty good design in here in that they have a very small little passageway which pulls fuel through the case, through the bushing, past the bushings on the front and the back, and then back to the return. So it creates a pressure differential from the pressurized case through the bushings, and there's another little drilling for the rear bushing here, and out to the return. So they do a pretty good job of pulling fuel past the bushings for lubrication. But these, I've never seen the bushings fail. It's always a cam roller interface failure. So what our bypass kit does, comes with a block like this and a few other parts. This is the key part. That bolts there, metering unit comes off, metering unit gets replaced here. And what that does is it splits the flow so it no longer feeds the metering unit from down here. Now it feeds the metering unit directly through this block, but also allows flow through here. So there's full flow going through this passage into the case still, and full flow going through this regulating valve, because this valve just maintains pressure in the system. All the extra flow coming from the electric pump flows out through this valve and back to the return. So this is constantly full of fuel and constantly pressurized, and there's always fuel flow going through that system and out through the return. All we're doing with our kit is we're splitting off clean flow that's not been contaminated by the bottom end of the pump and sending it to the metering unit and then your injectors, rails, and the high pressure system. So that has worked very well for a lot of people. There's literally thousands, many thousands of these out there in use. We are working on, we're always constantly evaluating products and designs and improving things. We're actually working on a Gen 2 version of this, which will be easier to assemble for customers, as well as potentially a little more protection yet. There's really only two ways that you could still get some debris on your metering unit and potentially into the injectors with our system, with our kit on here. That would be one, that the debris generated in the bottom end of the pump here from the cam and roller, trying to flow out through the return, block this screen or plug this return flow up completely or drastically restrict it, and then there's not as much flow carrying the debris out and away from your high pressure system. So if that happens and blocks up here, there's still a lot of pressure and a lot of flow coming from your electric supply pump that's just cramming it into this case, constantly lubricating and cooling the bottom end. But if there's no flow path out because the debris blocked it, it's going to basically just deadhead it into the bottom of the pump and contain it in the bottom of the pump. Because of the way of how close this is, it's very unlikely but technically possible that it could try to puke back through these passages because of the motion in the bottom with the cam rotating and the plunger or the buckets moving. It would have to go push debris back through this screen up into the block backwards against the flow and to the metering unit, which has the screen on it as well. But the screen, the micron level on the screen isn't enough to protect the injectors completely. Like I say, it's very unlikely but technically possible in that scenario that it could try to do that. That would be, other than that, you could potentially, the flow, the debris that's going back to the tank through the return, if it made it through your filtration system, if your factory filtration or whatever your normal filtration system failed, it could potentially allow some to pass. But that's very unlikely also. Even in the event, we've yet to confirm any out there. Like I say, of the thousands, 99+% have great success. We've heard a couple cases where somebody said they had a system fail and they found some debris on here. We've yet to confirm that it's actually damaged anything in the high pressure system, but regardless, even if it were able to try to do that, the amount of debris that is contaminating the metering unit is drastically different if you have our bypass kit versus not. If you don't have our bypass kit and it plugs the return, every bit of it can only go to the metering unit at that point, and it's going to directly contaminate very badly your whole high pressure system, and you're going to have to buy a whole new injector set and lines and everything. With this setup, everything's basically contained in the bottom end of the pump and can't leave. So if there is anything, it's going to be a fraction of what would have been introduced into the system if you didn't have this bypass block on here. So it's a very good setup and really cheap insurance for guys with a very expensive high pressure system and truck. But just because we're always trying to make things better, we're working on improvements to that, like I mentioned. So in the next few months or so, probably into early next year, we'll be looking to release a Gen 2 and also looking at ways that we can potentially even have detection of the failure detection, that we could alert the customer driver that they have a problem and that they need to shut it down before they continue to create more catastrophic damage. So there's other products that we're working on as well to remedy some of these CP4 concerns, and we'll keep you guys posted as we are ready to release some of that information. Unfortunately, there's plenty of knockoffs now and copycats out there, so we're having to be a little conscious about releasing too much information too soon. This, for example, has now been cloned by some other ones or some Chinese imports and things like that. We keep our stuff all US made and as high quality as possible, and we'll continue to develop more products as we can and keep you notified. If you got questions, let us know. We'll try to put together a couple schematics to show how the fuel flow works in these kits and in these pumps. There was some confusion about a Venturi port existing possibly in these or getting blocked. That doesn't exist in these. Really, the only two small passageways are the ones that are pulling fuel through the bushings in the front and the rear, like I mentioned. So we'll try to continue to produce more technical information to educate people and let them know why we do what we do and how their vehicles work. Thanks for listening.